Okay, in this assignment, we're going to be looking at work and power, which are both ways to describe how something gets done by using forces. So, in the past, we've looked at forces, which are acceleration applied to a mass, where you get an object moving faster and faster, slower and slower. You start it or stop its motion. Now, we're saying if you continue to apply that force for a certain amount of distance, how much do you get done? How much work do you do? Okay, work is measured in joules, and it's shown here in this equation as W, and over here and there. So work measured in joules. Okay, and again, it's about how much you can do, how much you can get done. Force is how you accelerate an object or how you decelerate it, how you change its motion. We've seen force before, measured in newtons. All right, our D here stands for distance, which we are measuring in meters. Okay, so this is one of the equations that we can use to deal with work and force and distance. We have a couple others here. One of the other variables we need to watch out for is P. P stands for power. It's measured in joules per second. Okay, work, like energy, is measured in joules to basically say how much you can do or how much you actually do with that force. Power is about how fast you do that work. Okay, so if you take your work in joules divided by some length of time it takes you to do that work, then you have power. It's essentially like speed, but instead of for how far you go, it's for how much you do in that time. All right. We can calculate power by using our work divided by the time it takes, where this delta t, that delta is that triangle letter right there, it's a Greek letter. And we got our t for time. This is our change in time. Change in time. Okay, which is how much time it takes to do the thing you're doing. Okay, so it doesn't really matter the absolute time that it takes in a day. You know, like if you're doing work at 3 o'clock p.m. versus 6 o'clock a.m., doesn't really make a difference. But if you do the work for 30 minutes or 30 seconds, that makes a difference. Okay, it's about how long time has passed, the elapsed time, rather than what time during the day something happens. Okay, so this delta t is the change in time. It's the time period that takes place as you're doing the work. Okay, this last equation is essentially just putting these two together. If you don't really know offhand what work is, like how much work you've put in to do this job, but you do know the time it's taken, and you know the force and the distance that you put together to make the work happen, you can swap this in for the W and make our work equal to force times distance on the top, and then divide it by our change in time there. It kind of just saves you the two-step process of having to calculate your work first and then plug it into this equation. We can just kind of switch it in for the top and say force times distance divided by our change in time should be equal to the work divided by the change in time, which is equal to power. Okay, so this last equation doesn't bring anything new to the table. It's just kind of a way to condense a bigger, longer problem. Okay, each of these equations works in different scenarios and different situations. So the first thing we're going to do with any of these problems is figure out which one we're going to use this time. So in this first problem down here, number 1, we want to solve for distance d that's measured in meters. If we're given the work is 200 joules, we do 200 joules of work, and we are applying a force of 4 newtons. We don't know what the distance is. So what I'm going to do is I'm going to pick an equation first. So out of these three, I don't have anything for power. I don't have anything for change in time. So I kind of wouldn't be able to use either of these unless I had some more information. So instead, this equation looks like it's going to fit best. So work is going to be equal to my force times the distance. Okay. Now I know some of these, so I know what the work is that we've done in this problem. It's 200 joules. 200 joules. Okay, so I'm swapping that in for my W, which is kind of like my placeholder for how much work I've done. I also know that we've done 4 newtons of work. So I'm going to put 4N here for 4 newtons. I still don't know what the distance is, so I'm going to leave that as D. It's a variable, kind of like an X. It's a missing thing I'm going to have to solve for. Okay. Now, to show that these are being multiplied, there are a couple different ways you can do it. You can do a multiplication sign. That's kind of the classic, but it kind of gets confused for an X sometimes. We don't really want that to seem like another variable, so I'm going to cut that out. Okay, we can do a dot, like I have in the equations up here, but sometimes those also come off as, it becomes unclear which things are units and which things are variables, because they're all just kind of together. Like, is this 4 times some variable n times d, or is n a unit, is d a unit? It's kind of wacky. So instead, my preferred method for this is to use parentheses. I like to put everything in parentheses, so I can tell that this 4N is 4 newtons. It's a measurement of force. Okay, it's not 4 times something I don't know, which is being place held as N, times D, which on its own is just a variable. Okay, so my 200 joules is going to be equal to 4N, 4 newtons, times some distance that I don't know yet. And my goal here is to get distance equal to something, some amount of meters. So I've got to solve for it. In math, whenever you want to get something solved, you need it to be alone. So I want d equals with nothing else next to it. Right now I've got 4n times d equals 200 joules. So this 4n kind of needs to not be there, okay? I can't just plug this into my calculator and say, well, I'll just put together 4n times d, because 4 newtons can't multiply to a number I don't know. I don't know what this d is. I know that when I put these together and multiply them, it's supposed to be 200, but at the moment, I don't know what that thing is. That's what I'm trying to figure out. So I'm going to try and get this d alone by getting rid of this 4 newtons that's next to it, that's multiplying to it. Okay, now, if I want to get rid of something in math, I have to play a game of opposites. Okay, so if right now this 4 newtons is being multiplied and I don't want it to be there, to get rid of it, I need to divide it. So if I divide this by 4 newtons, 4 divided by 4 is 1. Newtons divided by newtons is nothing. I can just kind of cancel that out. Anything divided by itself is going to be 1. So 10 divided by 10 is 1. A million divided by a million is 1. And then if you have that 1 times something or divided by 1, then nothing really changes. Multiplying by 1 or dividing by 1 doesn't change your math. Everything stays the same. So we can kind of think of it like we've canceled this out, like it's gone. So my 4 divided by my 4 is canceled out. My newtons divided by newtons is canceled out. So I essentially am left with just d on the right side, which is great. I want my answer to be d equals something. And it doesn't really matter whether my d, or my missing thing, is on the left side or the right side. So I'm going to say d equals. Okay. Now, unfortunately, I can't just leave it there and say, well, problem's done, because then that would say that d is equal to 200. So if I took 4 times 200, that's not going to be 200. That doesn't make sense. Okay? Whatever I do to one side of the equation, I have to do to the other. Okay, this equal sign says that everything has to be equal on the left and the right. So if I decide I want to divide everything on the right side by 4, I got to divide everything on the left by 4 as well. Okay? Now this I can plug in my calculator. I can take 200 divided by 4 and plug this into a calculator, and that should give me 50. Okay, 200 divided by 4 is 50. The unit for distance is meters, so I'm going to put a little m there for meters, and that's my answer. Okay, in order to do 200 joules of work with 4 newtons of force, I would have to apply that 4 newtons for 50 meters, which is quite a while, quite a distance there. Okay, so that's one example of how we can use these equations to solve things out. Let's do another. let's look at number 2. Solve for power, P, this guy right here, measured in joules per second if, and we're given some stuff. So, again, first thing I need to do is pick an equation. So out of these things, well, I'm looking for power, but I don't have the force and the distance. That's not given to me. So if I want to solve for power and say P equals something, I should probably pick the thing that I can just plug everything else into. The only thing I can have missing is power. So my power, P, is going to be equal to my work, which is W, up on the top, divided by the change in time, which is my delta T here. Okay, now I know the work and I know the change in time, so let's plug those in. So I want to plug in this 40,000 joules as my work on top. 40,000. I'm going to leave out my comma so it doesn't look like a period, like it's a decimal place. Okay, I'm going to have 250 seconds as my change in time on the bottom. Okay, so in this case, I can take 40,000 divided by 250. I don't need to do any algebra to move stuff around. This is already good to go, which is kind of nice. Not every problem is going to require algebra of you. So in this case, I'm just going to plug that into a calculator. So I'm going to take 40,000 divided by 250, and I get 160. Okay. The unit for power is joules per second. So I'm going to write J/S for joules per second, kind of like meters per second or miles per hour, except we're doing it for an amount of work done in a certain amount of time, so it's joules per second. Okay, and that's my answer. My power is going to be equal to 160 joules per second. Every second that goes by, we're doing 160 joules of work for this rate. Okay, let's look at another. Solve for the change in time, delta T, measured in seconds, if, okay, we got like 4 things here. So what equation am I going to use this time? Well, I do have power, so I can't really use this first equation because power's not in there. I have force and distance and change in time, which are all in this last equation here. So this is probably my best bet. Okay, so let's write in my equation down here. Power, P, is going to be equal to, okay, on the top, we have our force, F, times our distance, D, divided by our change in time, T. Okay, and I know some of these things. In this case, I know what the power is. It's 132. This is going to be kind of close. 132 joules per second. It's kind of squeezed in there. That should be equal to my force times my distance divided by my change in time. I know the force is 5.5 newtons. Whoops. .5. Oop, that's kind of a bad 5. 5 newtons, or 5.5 newtons, times my distance, and again I'm going to use parentheses so that way I can kind of keep this together. No, that's just my force. This is going to be my distance of 2 meters. Okay, and if I take that and divide it by my change in time, I should have my answer. Except I don't know what this change in time is, so it's just going to be kind of its own missing variable. Okay, this is like our X, or our question mark in this case. All right, I'm going to scooch this over a little bit. There we go. So if I knew the force and the distance and the change in time, I could just plug that all into a calculator and I would get 132 joules per second. But I don't. I'm missing this thing. So I need to get delta t alone. I need to get this change in time alone. Now this one's kind of a little nastier than the other problems because I have this thing on the bottom. Okay, this thing I'm looking for is going to be on the bottom. So let's say I wanted to get this 5.5 newtons and 2 meters out of the way. And right now, they're on the right side because they're being multiplied. So I say, you know what? I'm going to get rid of them by doing the opposite. That would be a very valid thing to do. And that could work, except if we go and get these guys off the right side and over to the left, well, then this guy's still on the bottom. Okay? I want my answer to be delta t equals something. Okay? Not 1 over delta t equals something. If I get rid of these guys and I don't move this guy, he's still going to be stuck on the bottom. It's not like once the top goes away, he's like, oh, yeah, no, I'll just get to scooch to the top. No. He's being divided for a reason. We're taking this divided by change in time. So unless I do something opposite of this to move him somewhere else, he's going to be stuck on the bottom, and that is not what I want to solve for. It's going to be upside down. It's going to be inverse. Okay, an inverse is going to give you a totally different number. And you can try this for yourself. You plug it in your calculator. If you take 1 divided by 2, it's not the same as just 2. Okay, so 1 divided by change in t, our delta t, our change in time, is not going to be the same as just the change in time as is. So what I would recommend doing in this first step is actually to deal with this guy first. I do not want him in the denominator down here. I want him in the numerator. I want him on top. I want him to be multiplied. So right now, if he's being divided, and I don't want him to be divided, the opposite thing that I do is multiply. Okay, dividing is the opposite of multiplication. So if right now he's being divided, I'm going to have to multiply to get him in a place that I'd rather have him. So I'm going to multiply here by my change in time. Okay. This way, my change in time divided by my change in time, it's going to go away. Okay. And again, this equals sign means I can't just only do it to the right. I have to do it to the left too. So I'm going to also multiply by this delta t over here on the left. Okay. So it's essentially gone on the right side, but it's shown up on the left side. And now it's up in the numerator with everything else. So what I get is going to be, let me see if I can copy this down and clean it up a little bit. Okay. So I'm going to end up with this stuff going away. This stuff is still over here. Okay. So essentially, by multiplying both sides by my change in time, I'm going to have the change in time that I don't know times 132 equals 5.5 newtons times 2. Okay. So there's a couple more things I have to do before I can have this problem solved, but that's the nasty part. Okay. That's the part where people always get tripped up, is they don't get that guy off the bottom where it's being divided. Okay. So the next thing I would do is the easy part. Okay, which would be, this is just a number and this is just a number. I can multiply these. 5.5 times 2, it's just going to be a number. So I can plug that into a calculator. Okay, 5.5 times 2 is going to be 11. My units haven't canceled or anything, so technically this would have a unit of Newton meters, which sounds kind of weird. Okay, and sometimes we'll put a little dot there to show that it's not like a prefix or something. It's not like nanometers or something. It's the unit of newtons times newtons, not newtons, the unit of newtons times the unit of meters. But if that kind of gets weird, you can always kind of wait until the end of the problem and say, my answer is supposed to be in seconds. So as long as my math checks out, then I'm going to make my answer in seconds at the end. Okay, so my change in time times 132 is going to be equal to 11. Okay, the last thing I need to do to figure out what this is to get rid of this 132. Now, what I have is that my change in time times 132 is this. So what is this missing piece? Okay, let's see if I can do one more of these. Squeeze this in. Scooch that up there a little bit. Okay, and I'm gonna scooch this down. Okay, copy this. What will we do without copy and paste? Okay, so our delta t times this is going to be equal to this. To get my delta t alone, the last thing I need to do is to divide both sides by 132 joules per second. Divide this by 132 joules per second. Okay, and this is going to be a really small number, which is going to kind of make it feel like it's wrong, but that's okay. We have 5.5 newtons going across 2 meters. That gets a ton of power out of this. Okay, that means we're doing a lot of work. So this must be done in like a very small amount of time. Okay, because 5.5 newtons isn't a whole lot of force, and 2 meters is not a whole lot of distance. So our power coming out to be such a huge number means that we're probably doing just some amount of force over some small distance in a very short amount of time. Okay, so on the left side, 132 divided by 132 cancels out. Okay, and then this is just going to be a number. So I kind of ran out of room down here, so I'm just going to kind of scooch this over to the right. So my delta t is going to be equal to 11 divided by 132, which gives me 0.083 and then a whole bunch of threes. 0.083. I could say 3, I could do 333, 333. I could do one of those fancy little lines that says it's repeating, but I'm just going to write 0.0833. Sorry. Okay. My unit for my change in time is seconds, so I'm going to put a little s there, and that's my answer. Okay. Not a lot of work being done, but in a very short amount of time. So the rate of the work is very, very big. Okay. So that's all 3 equations. Again, watch out for the trickiest stuff where you've got to get your variable off the bottom first. Okay, get it out of there, or else your answer is going to be upside down, it's going to be inverted, and it's not going to be correct. Okay, remember that some problems will require no algebra. You'll just have to plug stuff into your calculator, and then you've got it. So don't feel like you always have to be doing some multiplying and dividing of things going left and right across the equal sign. There are some cases where you just plug it in and you're done. Okay, so it's not a trick. Sometimes that's just all it takes. Okay, and remember, if you do have to get something moved around from one side to the other to get a variable alone, always do the opposite of what it's currently doing. If you're trying to get rid of something that is multiplied, you divide it. If you're trying to get rid of something that is divided, you multiply it. Okay? So hopefully this helps. The rest of the problems are just going to be other versions of these. So if these make sense, hopefully the rest will make sense as well.